This is Mrs. Vrobel. This is the second of two videos. So in this section, we're talking about naming compounds from formulas. And for some students, it might be challenging to do. And I have a flow chart just like I did with writing names. So I want you to use that to help you decide what's going on. So in this first worksheet here, they have the following ionic compounds. Now please remember, on a quiz, you're not going to have a separation between ionic and covalent, so you need to figure out what's the difference between the two of them. So let's start with, we'll do this formula here. So NH4 and notice that there's parentheses around it and then SO4. Now, if you look at the top of this flow chart here, we have NH4 plus. It is the same compound. So this is an ionic compound. And if that's the case, we want to write the positive ion first. So the positive ion, we need to determine what it is. Now, if you look here, it is ammonium. So when I write my name, I want to write ammonium. And then what is the negative ion? Well, notice that it's not monoatomic, it is polyatomic because it's got parentheses. So when that happens, you need to go looking on the chart. Oh wait, I'm going the wrong direction, guys. Okay, so I want to look for SO4. And when I look for SO4, it is right over here. And notice that it is sulfate. So when I write the name, I want to write sulfate next to ammonium. Okay, that actually wasn't too bad, but I want to do an example where, okay, maybe we have to figure out what is going on with the charge here. So the next example I'm going to use here is this one here. So when you look at the formula, notice that we've got a couple different things going on. We have a polyatomic, but we also have a type 2. And when you're talking about a type 2, we're essentially talking about a transition metal. Okay, so we have to do some algebra to figure out what is the charge on the metal. Because please remember, transition metals can have more than one charge. All right, so the first thing we want to do is we want to figure out what is the charge on it. Okay, so we're going to have to do some reverse algebra here. Okay, so I'm going to write Fe, and instead of going straight to the charge on the metal, I'm going to actually use the nonmetal to help me figure out what is the charge on it. So I'm going to write CO3, and I'm going to scroll down and look for CO3. And when I look for CO3, it is actually here, which is carbonate. So I'm going to write CO3 2 minus. And I want to set up algebra so I can figure out what the charge is. Now, you have to be careful because there's two subscripts here. So what I want to do is I want to write 2x because iron has 2 for its subscript, plus CO3, which is carbonate, has a 3 as its subscript, and I want to include its charge and set that equal to 0. So when I solve for the algebra, I'm left with 2x minus 6 equals 0, and when I solve for x, I get 3. So the charge on iron is going to be a positive 3. So notice I want to use a Roman numeral ion charge. And I'm going to write the name, which is iron, and I'm going to use Roman numeral 3. And then I need to determine the negative ion. And since it is not monoatomic, so there's more than one nonmetal, I want to use the name that is listed for that polyatomic, which is carbonate. So this becomes iron 3 carbonate. Okay, so those are two examples of ionic compounds. And now we're going to switch gears and write names for covalent compounds. And you probably think covalent compounds are probably a lot easier, and you would be right about that. So if you look at covalent, there are no metals present. And if we look at our first example here, which is Br2I4, we're going to use prefixes, except if you have a subscript of 1, you are not going to use it with the first element. Now we have a subscript of 2, so we're going to use the prefix di, and we're going to write the name of the element, which is bromine. And notice that there is a 4 there, and from the previous video you should know that 4 represents tetra. Now, some people will drop the A and they will just call it tetraiodide. It's up to you. I'll let you just put in iodide. And please remember, we're changing the ending, so iodine becomes iodide. So that is pretty easy for covalent compounds, and I'm assuming that you should be able to get the rest of them. Please remember, you don't want to reduce down any subscripts because that does not happen with covalent compounds. Okay, so if you have any questions, just contact me and make sure you submit this so I can check it. Have a good day.